So number 12 says tangent to the fourth of x minus 9 equals 0 from negative infinity to infinity. By the way, I have a mountain of grading to get through. I hope to have your quizzes back tomorrow and your homeworks back on Monday. That's my guess. But I have a deadline for something I'm applying to this Friday, so we'll see what happens. Okay, but I'm going to work my best. So right here, step 1 here is we need to add 9 to both sides. Remember, we're trying to isolate x. And again, if you've already done this, great. You can work on more problems on this sheet silently. By the way, how many people are going to be with me as I do this problem? Just by a show of hands, please. Okay, virtually everybody. Again, if you're not with me, totally fine. Okay, I'm going to take, so somehow I've got to get rid of this exponent right here, this quartic exponent. So the only way to get rid of that is to take the square root twice. That's all you're going to want to do. Take the square root once. I'll have tan squared of x equals, and I'm seeing a lot of people in the other classes are forgetting the plus or minus.
So it's always plus or minus?
Anytime you take a square root. Every single time you take a square root. Now we have a squared, so let's take the square root again. Tan x, take the square root again, plus or minus root 3. Robert.
Is there like another plus or minus in front of the 3?
There is, but like a plus times a plus is still 1 plus.
Oh, okay.
Right? And then it's like, there is another one, but like when you actually like work all of those scenarios out, you just end up with a plus or minus. That's a good question. So tangent of x. So here, you know, I would just remember that these are really like two different equations, right? Like one of them is this, and the other one is this. Just two equations, so we need to solve each equation. So again, if you don't remember this off the top of your head, which a lot of us don't, think back to the graph for tangent. Remember we have asymptote here at pi over 2. Remember we have an asymptote here, negative pi over 2. Remember, we always said, remember the asymptotes, and just remember one more point. Pi over 4 has a tangent of 1. We know that because remember, tangent is sine divided by cosine. Sine and cosine are both equal at pi over 4, hence tangent is 1. We also have down here negative pi over 4, where the tangent is negative 1. Remember, tangent is an odd function, so when you switch the x's, you also switch the y's. So for this piece right here, where we're asking where is tangent positive radical 3, we need to remember that radical 3 is bigger than 1, so way up here. There's only one angle between pi over 4 and pi over 2, and that's pi over 3. So x equals pi over 3. Let's focus on the negative side, and we'll come back at the end and take care of this infinity piece. So on the negative side, we're asking where do we have negative radical 3? So negative radical 3 is down here somewhere. Only one angle between negative pi over 4 and negative pi over 2. Of course, that is negative pi over 3. This should make sense. Again, tangent is an odd function. Switch the x's, and the y's switch as well. Janae. I'm not going to add 2 pi k this time. I'm just going to add pi k. Does anybody remember why pi k? Because the period of tangent is pi. The period of tangent is pi.
Chef,
Mr. Pankow.
whenever you were saying for for, and since it's odd, you can switch the x and y values.
Mm-hmm.
But still on the graph, we kept the square root of 3. I mean,
But I did like negative radical 3 here, and this was positive root 3. So I switched the y values.
and then split that.
And then I switched the x values. There's a
Oh,
positive pi over 3, negative pi over 3.
alright.
You sure?
Yeah, I got it.
Okay. So other questions on number 12? Okay, let's go to number 14. So, 14, oh, sorry, 13, that's more vexing. 13 is a long problem, but it's doable. So, let's do it together. Alright, so number 13, so the one right below it, says 3 secant squared of x equals 3 plus 4, and I'll unfreeze it in 1 sec, for sine squared of x from negative infinity to infinity. Remember, step 1 is you need to write down like the various identities you might use. So I just start on the left and go right. So secant of x equals 1 over cosine of x. Bless you. Number 2, secant squared, we remember, is 1 plus tangent squared of x equals secant squared of x. That's a Pythagorean identity. The first one was a reciprocal identity. Clearly there's no identity on the 3, no identity on the 4. Sine squared, we know that sine squared plus cosine squared, this is the first Pythagorean identity, equals 1. So those are the 3 possible identities. Who knows which one we're going to use? Because we don't know going in, but we want to just write them down. The only thing that I know for sure is that because this is an equation and not a proof, I want to get all my terms on one side and set everything equal to 0. But before I do that, I want to know, like, maybe are there some identities that could make sense? And when I look at this, it seems to me that identity 1 and identity 3 are going to be good. And the reason is because if I use identity 1 over here, this will only have cosines. And if I use identity 3 over here, I'll only have cosines. So then I will have only cosines in the whole problem. And that's definitely better than having secant and sine. So I'm going to use identities 1 and 3. Are there questions of why I'm using those identities? If so, please ask. Okay. So over here we've got 3 secant, remember, is 1 over cosine, so 3 secant squared is really 3 over cosine squared, because remember, secant is just 1 over cosine, and that equals, the 3 is going to stay, plus, and now somehow I got to get rid of the sine squared, so for that I just want to rewrite this as sine squared of x equals 1 minus cosine squared of x. So this pink box is the same as this pink box. So I'm just going to replace this sine squared with this. So it's going to be 4 parentheses 1 minus cosine squared of x. Okay, I'll go ahead and distribute over here on the right. I'm going to combine like terms on the right side. Left side, again, I haven't even done much there yet. We will get there in a second. Remember, this is not a proof, so you are allowed to work on both sides. Remember, for proofs, please only work on one side of the proof. 3 plus 4, obviously, 7. So here we are. Now I'm going to just minus everything onto one side. You can pick, you want to move both of these over here, or you want to move this over there. It's totally your choice. I like having everything on the left side, so I'm going to move these two over to here. Go ahead and do that now. Now I'm going to move this over here by adding. Where this is of course all over 1. Any number that does not have a denominator, of course, has an imaginary denominator of 1. And of course, this equals 0. Here, you need to use the trick to combine the two fractions or find a common denominator if you prefer that. I prefer the trick, but again, if you prefer using common denominator, that's fine. Remember, the trick is bottom right times top left, so that's 3. Bring the sign down, that's minus, and then this cosine squared times top right. I did not keep change flip because it was not a okay, keep change flip would have been done if we had had this fraction divided by this fraction. We do not have that, right? Right, so I use this trick, right, that I've been talking about for a while. So the trick is bottom right times top left. Hold on, let me. So the trick is bottom right times top left. So bottom right times top left, right? Bring the sign down to minus. Bottom left times the top right, all divided by the bottom's multiplied. Now we have a slight error here. Marcus, you have a question? No. No. Okay, I didn't think so. This should have been a minus sign here, and the reason is because this negative, right, we're saying it's this fraction minus this fraction, so really these are in parentheses, which means this is a minus sign here. Negative times this will give us -7, which is what we wanted. Negative times negative will give us +4 cosine squared of x. So, in other words, I'm just distributing this negative inside, which is the only way that you can have this trick working. If you did not want to do it this way, you could have combined the 3 over cosine squared with the -7 first, and then combined that new fraction with the 4 cosine squared of x. Remember.
Maybe we just rephrase it and put the -7 at the end before cosine to keep the front positive without messing with anything else?
Yes, you could. You'll get the same answer. That's right. Absolutely right. So, Rombeer's way, which is, I think, a better way to do it, is rewrite this in the following manner. Rewrite this as this. This is actually a much better way to do it. And instead of having -7 minus this, just put plus 4 cosine squared of x minus 7 all over 1. Is this what you're saying, Rombeer?
Yeah.
Yeah, this is